the human eye is being replaced with camera systems. Most of these machines are now trying to see and understand the world. That's how the whole trajectory is going.
On this episode of Embedded Insiders, we're discussing why multi-camera synchronization is a key feature in cameras that enable industrial robotics, retail applications, autonomous mobility, and more with Maharan Verhabu, co-founder and vice president of product design services at Econ Systems. Next, Haiku Hutel, VP of software products at Harman International, joins us to discuss his company's role in the Eclipse Foundation's recent SDV working group, which is formed in an effort to develop an open source hardware platform that can be used in today's software-defined vehicles. But first, Embedded Computing Design is hosting our Smart Manufacturing Day focused on AI and machine learning infused automation and manufacturing on March 12th. Stay tuned to hear more about the virtual event. Good afternoon, and welcome to the Embedded Insiders podcast. I'm Tiara Oliver, Associate Editor at Embedded Computing Design, and as you can probably tell, I gave Rich and Ken the day off so I could tell you about the upcoming virtual event we're having in March. By now, most of us in the embedded space know what smart manufacturing is and what it means for the industry, but there are new advances in technology happening all the time. This year, we're of course bringing you a host of experts who will impart their valuable knowledge and experience in the field, but we'll also be zooming in on the use of artificial intelligence in the industrial field and what it means for the future of smart manufacturing. For this event, we'll be hearing from Industry 5.0 leader and founder Michael Rada, as well as Thorsten Stremlau, a distinguished engineer and systems principal architect at NVIDIA, and Matthias Huber, Senior Director of Solution Management at Supermicro. This free virtual event is happening on March 12th, but keep an eye out on our website for any updates. Now, here's Maharan Verhabu, co-founder and vice president of product design services at Econ Systems, discussing the key features of multi-camera synchronization and some of his company's solutions that can further support this transition.
So I'm Maharajan Veerabahu. I'm one of the co-founders of Econ Systems. So Econ Systems is basically into embedded vision cameras. We've been in business for the past 20 years. This is the 20th year. And we provide camera modules for a number of different applications like autonomous mobile rovers, autonomous retail checkout kiosks, as well as applications in robotics, in agriculture, and other areas as well. So my expertise is basically more on the embedded software, and I work a lot on camera imaging as well.
Can you explain what multi-camera synchronization is and, maybe why it's important in the context of camera systems?
So basically, like you have seen, cameras have moved away from just recording a video and capturing images. Now cameras are being used as actual vision systems where some data is taken out and being processed. Right. So a lot of applications depend on camera as vision systems. Now, when we talk about vision systems, I can actually see two main areas where multiple cameras are required. So one area is when I want to do a 3D reconstruction of a particular object, or if I have to understand how far that object is from me, like various points in that object, how far it is from me, and I can see it in a 3D format, right? So with a single camera, the output is more in a 2D format. So I need at least two cameras, just like a pair of eyes that we have, so that I can triangulate and understand the depth and the 3D part of the object itself. So there are options where I can use two cameras. There are situations where there'll be more than two cameras used to do this. So this is one area where multiple cameras are being used. The other area is to understand our surrounding and understanding the scene better. So one camera, you may not have the full field of view. Like you cannot have a 360-degree field of view without distortions with a single camera and lens combination. Of course, there are 360-degree kind of lenses, but it's with a lot of distortion. So, what if I have to understand a scene which is spread out? And I want to understand that at a particular instant, how the scene is. How do I reconstruct this whole scene, which is around me?
So, how does synchronization impact the overall performance and functionality of a camera system?
So when I'm trying to synchronize multiple cameras in one single host, I have to take the data from these multiple cameras into that system, into that host processor itself, right? So when there are multiple streams coming, and if I am trying to get multiple 4K streams or multiple HD streams, I need to make sure my processing is good enough so that I'm able to process these multiple camera frames simultaneously inside. There should also be, there should also be features in the hardware to accept these multiple streams simultaneously and do the processing as well. Now, after I capture these images from multiple cameras, each of these images, although they are captured at the same instant and they are in the same environment, the white balance of these different cameras might be a bit off, a bit different. So if I'm trying to do a 360-degree stitching, or if I'm trying to stitch these images together, we can see some color variations as well when I'm trying to combine these images. So this is another area where the performance and functionality has to be taken into account, and we need to do some processing, post-processing, to make sure everything is okay. These are the couple of areas where I can think of how synchronization affects the impacts overall performance. But from a use case perspective, combining these images actually gives a lot of room for algorithms from the processing point of view.
So, are there any common, software tools or software techniques in multi-camera systems?
Yes, actually, when I'm using multi-camera systems, I can do a synchronization over software, or I can do using hardware. So there are two ways to do it. In a software synchronized methodology, the latency becomes a big question. Now I can have all the firmware running on these cameras receive a particular command so that they start. They start the frame capture. So it's basically the exposure has to start, and you start capturing the frame itself. Now, if I'm having a software, there are delays and latencies in the software inherent to each of these cameras. So it'll not be like a perfect sync when a software sync is used. So in many cases, we prefer a hardware sync. So a hardware sync is more cleaner, and you can expect a more perfectly synchronized frames coming out of all these cameras. And in hardware sync, also, there are a couple of ways how we can achieve this. So we can have like a master signal, a clock, a trigger pulse kind of a signal, which goes through all the cameras. And these cameras have something like a strobe where once the signal comes in, the actual capture starts happening. And if I'm giving the signal to all these cameras, then all of them will start the frame capture simultaneously in that particular uh, millisecond or microsecond. Now, this is one way of doing it. The other way is to have one master and multiple slaves, where you can have this one master send the trigger pulse to all the other cameras, so that all the other cameras are synced with the master, and the capture happens. So in this case, from the stroke, from the signal to the capture, that time is more deterministic, and so it'll not be like software. So these are the various techniques how we do synchronization in cameras from software as well as hardware.
So, when it comes to multi-camera systems that are out there today, can you explain some of the camera systems or the multi-camera systems that Econ Systems has out right now, and maybe how they differ from maybe some of your competitors?
So we are offering a number of different multi-camera systems. Like in our website, we have a whole division allocated to multiple camera systems. And one of the main processing platforms that we use is NVIDIA. So we have multi-camera systems attached to a NVIDIA processing platform. And there are right from 2 cameras, 4 cameras, 6, and even 8 cameras connected to NVIDIA processing and Jetson platform, and we also provide the entire software stack where all these cameras are synchronized, and we are able to receive these frames into the system. And these development kits are basically ready to buy from our website. So anyone who's going to explore this, if they are trying out new things, they can go to our website, look for our multi-camera systems. We have a camera selector page where they can choose what are the requirements and pick the right system for them and buy. And it comes along with the software for them to play around. And apart from that, we also have a 360-degree stitching algorithm, which stitches all these images. And we also have worked with applications where we give a 360-degree view of an autonomous mobile rover or an autonomous vehicle and things like that. So these are software stacks which are readily available, which we give to customers on request. So if we have a customer who is looking for to build a system like that, we can give a demo of these ready-made software stacks on top of these hardware platforms that we are selling right off our website. So one of the key differentiations that I would say that Econ has is the number of different multi-camera options that we have, and all the ready-made software as well as application stack that is available on top of it, and our experience in working with multiple different customers to perfect these algorithms that we have on top. So I think that's a big differentiation I would like to point out.
Awesome. So you mentioned some of the different industries and some of the different customers and all of your different camera solutions. So aside from the autonomous vehicles and autonomous robots that you previously mentioned, are there any other industries that your cameras are best optimized for?
Yes, we have been using it for like remote driving applications where a 360-degree view has to be very seamless so that there's no that remote driver fatigue does not come into play. So that is one area. We have used this in retail areas as well, where we have used in applications where we have used in autonomous checkout kind of applications where we have multiple cameras on an aisle. We have these on rovers going inside a retail store, which does like inventory checking. So multiple cameras in that as well. And there is an interesting use case in sports, which we have dealt with as well. So we have worked with cameras where there is a big camera system which does capturing of an entire sports field. It could be soccer, it could be tennis, it could be any kind of sport, but it could capture the entire ground or the playing field. And there are multiple cameras involved, and it's a happening place. So it's a sport. It's people are moving, but with a synchronized camera setup, you can capture all these frames and stitch them into a larger video itself. So we have worked on applications in sports as well, and also in some agriculture. Again, when I talk about agriculture, it's basically the tractors or equipments which are on the field, which are used for de-weeding and things like that. So that is another area where we have used multiple cameras to detect depth and also to understand the surrounding.
And then, in your opinion, how do you see the role and growth of multi-camera synchronization evolving, in the future? And are there any trends or challenges that you foresee?
See, for me, the way I'm seeing it is like 10, 15 years back, like when we started, when cameras started becoming more and more common in embedded devices, right? More often than not, it was just one camera. But nowadays, any product that we take, there are multiple cameras in each of the product that we're using. For instance, even a cell phone, right? A small cell phone has more than two cameras today. And if you take the automotive, there are like 8 cameras, 16 cameras, and the count keeps on increasing. And this is the same thing I'm seeing with every application. They want more and more sensors. One of the reasons is because these sensors are becoming more and more cost effective. They are consuming lesser and less power as the technology keeps improving, right? And most of the processing systems today accept a number of camera inputs inside them as well. So multi-camera is what is going to be the future. Like any product that we take, I think we have to deal with multiple cameras. And some of these applications may not require a synchronization per se, but they would at least require, working together. All these cameras working together, getting all the feed. But there will be more and more applications where synchronization is coming into play because the human eye is being replaced with camera systems. Most of these machines are now trying to see and understand the world. That's how the whole trajectory is going. And when that comes into play, more than one camera, which are synchronized, is very much required so that they understand the 3D part of the world, number one, and also the understand the world around them much better. So I think it's going to go on a ramp. And what I would recommend is if anyone is trying to work on these camera systems, I think they should start playing around with multiple cameras, synchronizing the images, and working on algorithms which can improve this or which can take advantage of this multiple camera synchronization. And if anyone is interested, I would recommend them to play around with the kit and understand this better. So nothing like trying it out.
Now, Rich and Heiko Hotel, VP of Software Products at Harman International, take a look inside one of the top trends in the embedded space, software-defined vehicles.
So the first question has to do with the build or buy question that we come across all the time. What are the challenges that your team faces when making this decision?
Good question. At the end, I usually tell people we should stop talking about make or buy. We should start thinking about make, buy, partner, open source. Proof in that. At the end, there is, besides automotive, there are other industries we are all aware of. And they have solved tons of problems the automotive industry has. So when it comes to constrained edges, what a vehicle certainly is, you need certain smaller footprints of software. You need certain more hardening, more secure, more safety. But at the end, you need the same technologies as in clouds, as you have on a different other spaces. So that's why I truly believe making things on your own, well, only if it really differentiates you.
So what excites you and your team most about working with software-defined vehicle platforms?
Yeah, at the end, I keep on calling it the third automotive revolution. And I think the shift from our heritage, to be honest, of hardware defined to software defined introduces a totally new paradigm in how we need to think about. And that's why I truly believe that the shift from that basically your software is defining the hardware you need in the vehicle is clearly a huge one. And if we compare it back to the early 2000s, where if you have been in the data center business, you discussed religiously about Sun, IBM, Oracle, DB2, and all of these things. And nowadays, what do you discuss? Cloud. And basically, what is a cloud? A cloud is a software-defined data center. And the issue is software-defined vehicle, we have not come up with a fancy name like cloud for it. So that's why people potentially don't get it. But at the end, it's the same story. And this is where I truly believe in that revolution. And if we take a look at data centers and what happened there, the trend towards cloud, it's two major open source projects which paved the way. One is Linux, the other one is Kubernetes. And clearly, now with the Eclipse Foundation SDV working group, for example, we have all the power in our hands to shape that future. It would have been stupid to not do that.
What are some of the bigger challenges that your team faces when designing for the software-defined vehicle?
So people believe they need hardware on their desks to test out software. No, you don't need that. You simulate nearly everything in the cloud, but you need to design for it. And this is this is again this fancy shift from hardware defined to software defined, that we need to understand that the design of our hardware needs to follow how we think about the software. And that because it changes drastically your time to business, your time to market, and the way you develop software, and also the costs associated with it. And this is why the future is software defined in, I would say, close to every industry.
Are you currently using open source software as part of your technology?
Sometimes I think people don't even recognize it, but most of the people are using open source software. When it comes to actually to Linux being used in automotives as the operating system for infotainment, when it comes even to Android Automotive has open source pieces, and some of our tool chains, container runtimes, applications, and so on. So we use tons of open sources. Clearly, yes, we do use open source. We have not been, as Harman, not that vocal in participating in such communities. But with our official launch on February 6th, we are changing that drastically and will be vocal about it, even becoming a strategic member of the SDV working group.
Can you talk about that a little bit? I mean, obviously, this is going to be used in April, so something that you're announcing in February, we won't talk about.
At the end, we have signed all of the documents, but we agreed to send out a press release on February 6th that we joining the Eclipse Foundation, B, joining the SDV working group as a strategic member.
Oh, nice.
And overemphasizing on our commitment to open source, that we're also contributing some of our current software assets to the Eclipse Foundation.
Excellent. Okay. What are the most important skills that a developer should have who's looking to get involved in software-defined vehicles?
It's actually, there are two things coming together. If you take a look at the automotive community currently being used to develop stuff embedded, I encourage these people to take a look at cloud native as an overarching term, and especially container technology, Kubernetes, and so on, how things are built there. Rust as a programming language will play a very, very important role in that world in the future. So these are the technology portions, and then also the thinking of distributed applications, of adaptive application behavior, things where people coming out of the automotive world need to actually start more and more thinking about how can some of the heavy lifting you don't need in the cloud also be eliminated within everything vehicle at that point.
Why are you joining that working group?
For me, it's important that we collaborate on things which only need to be done once. And very simple example, building an automotive-grade container runtime that can be done once in open source. I truly believe that everything we see in underneath a certain user experience, there is not much to differentiate. And then it's a clear sign that you can actually do that open source, and you should do that open source, because we all live in a world full of resource constraints, full of timelines we need to meet, and so on. So everything which is, let's say, pre-built is helping you to achieve your goals in terms of reaching SOPs and stuff like that.
Excellent. If we were to have this conversation 2 years from now, what would the issues we'd be looking at?
Oh, I think one is clearly how to bring that bunch of fancy tier one suppliers, including Harman, of course, together to not think that the other one is trying to rip them off. So I hope that we are not, that we are talking about how did we overcome this challenge. Second, I would clearly be happy to hear about that we have a wonderful reference distribution out there, which is able to fully end-to-end show how software in a native fashion can be built in automotive. I'm dreaming, but I think it should be doable.
Thanks for listening to this edition of Embedded Insiders. For more daily news, videos, and podcasts, visit our website at embeddedcomputing.com.